Diagnostics in histopathology is still based on slow and often subjective manual approaches. One emerging technology that can provide a solution to this problem is machine learning, or specifically deep learning. We believe that by automating routine tasks and quantifying various diagnostic parameters, deep learning algorithms will lead to one of the biggest transitions in pathology. Unfortunately, the adoption of these technologies into routine practice has been slow. One of the main reasons is the lack of infrastructure required for the digitization of histological specimens. Due to their high cost, many institutions and clinics still can't afford microscope slide scanners, and therefore they're not able to make a transition from traditional microscopy to digital slides. In addition to their high price, these systems are usually completely closed and use proprietary technologies and image formats. It's clear to us that these practices are slowing down science development significantly. Digitization is crucial because it opens the door for the use of computer algorithms and therefore deep learning and image analysis. Without a high-resolution and inexpensive microscope slide scanner, we can't expect widespread use of these algorithms in digital pathology, regardless of their potential. For this reason, this is the first problem we set out to solve.
This is Marvin, our second prototype, named after the robot Marvin from The Hitchhiker's Guide to the Galaxy. In order to optimize all the components, we designed Marvin from the ground up. Using off-the-shelf components and leveraging open-source technologies, we managed to achieve high resolution while still keeping the hardware costs low. Marvin is cool, but we understand that hardware alone won't solve this complex problem. We need hundreds of deep learning applications in veterinary histopathology, so the question is, who will build them? Besides digitalization, deep learning algorithms require a lot of labeled data, and labeling medical images can be time-consuming, and it also requires a domain expertise. Domain expertise coupled with time leads to high costs, and high costs are not very sustainable, especially in veterinary medicine. Also, having only machine learning experts train neural networks without any deep understanding of the underlying data can be inefficient and sometimes not so harmless.
Instead of building expensive and closed deep learning models, we want to create a new generation of veterinary pathologists that will have the skills and intrinsic motivation to do the whole end-to-end process needed to creating deep learning models. This maybe sounds far-fetched, but we already have 8 students of veterinary medicine on this project. They're all programming in Python. The key is to build a community, ideally around hardware, and in our case, that hardware is Marvin. For veterinary students, Marvin has a similar purpose to Raspberry Pi. As a programmable hardware, it serves as a great introduction into Python programming, but also as a stepping stone into more complex image processing. As a microscope slide scanner, it is a platform for developing and deploying their models. Our goal is to build 2 improved versions of the microscope slide scanner and test not only their hardware capabilities, but more importantly, how the idea of open programmable hardware can help us build community with the skills and domain expertise needed for creating deep learning applications we need in veterinary histopathology.